All right, let's do some MOCAP. Oh gosh. Would you, okay, this is a choose your own adventure at this moment. We could finish this. That's gonna take about a half an hour, and that'll be about the end of the review. Or we could not do this, which is more of the exam, which is fine. And I can take particular specific questions. Finish this.
Yeah.
Okay. All right, let's do it. Let's start with SN2. Yeah. This is another name for what in my class I called a substitution reaction. The generic is like this. It's a substitution. You substitute L for NU. L stands for leaving group, NU stands for nucleophile. The nucleophile will usually have a lone pair of electrons, and in addition will often have a negative charge, so it's easy to recognize. A simple example would look like this. And often the leaving group is a halogen, though it doesn't have to only be a halogen. Something like that. That would be a pretty simple example. Why did I not care about the Na+? It's a spectator ion. It's not the nucleophile. The nucleophile is negative. So OH minus is what I was looking for. I don't care about the counter ion, the cation. So just a mere substitution, one for the other. More complicated example, somebody reminded me of it today, which was really awesome. I don't know how I thought of this. It was on an old exam. Let me make it more fun. Okay, write the product. So you would have to recognize that here's your R, that's your organic, here's the leaving group, then this is the nucleophile, only the negative part, which in this case is listed first. Sometimes OChem people do that. So the negative part right there. So you would substitute the BR for that monster, okay? So the original part is this, and then you could either write, well, let me get a different color. This CH3 is, you could write it like that, or you could write it the opposite way if you prefer, though it would look identical. Oh, I forgot a C. You can write it like this, and the original CH3. Both are the same thing, but just to show you, you can add on either side, doesn't matter. So this would be kind of your average or easier type question. This just looks a little weirder, so a little more difficult, but same kind of question. Okay, so this is called an SN2, or in other words, a substitution reaction. It's one of the 4 reactions you've learned. Combustion, substitution, halogenation, and addition. Yeah. You could not, can you write the CH3s next to each other? No. The R group where the BR was attached has to be close to the negative part. So this and this have to be together. All right, next. Let's do some, oh gosh, hybridization. Okay. I want to know how many sp3 carbons there are, how many sp2, and how many sp carbons there are. Just as a review, you can think ahead if you'd like to, but as a little minor review, sp3, 4 groups, sp2, 3 groups, and sp would have 2 groups. Also remember that every carbon has 4 bonds. So if you don't see something there, that means there's an undrawn hydrogen. Okay, so I'll let you work on a little bit, and while you're working on it, I'll draw in all the undrawn hydrogens in green. Okay. How many sp3 hybridized carbons are there? We got more than one. There's one here and one here. That's all I see. So 2. Okay. How many sp2 hybridized carbons are there? 6. Well, let's see. 1, 2, 3, 4, 5. Did I miss any? Okay, one more time if you missed it. 1, 2, that one is 3, 4, and 5. Okay, how many sp hybridized carbons are there? 1, 2. I think that's everything. Okay? Any questions on any of those? Yes? Yes, even though the triple bond ends, there has to be carbon there, because what other atom could triple bond to something? Not a hydrogen. Just like this, there's a carbon there. All endpoints have a carbon. Yeah, and there's a carbon here. Same idea. Was there another question somewhere? No? Okay. Next. We're gonna do, oh gosh, isomers. Did somebody have an isomer problem for me? Because if not, those are tough to come up with. You have one, yes, there's the winner in the front. C5H, oh, that's a good one, yeah. I don't know, this might be really hard, I'm not sure. Where did you get this? I did this on a video, was it hard? Okay, the person in the front row is telling me this is really hard. I don't know if it's hard or really hard. Do you want me to still do it? Yes. Oh, okay, they don't care. So, it's okay, Joanne. So, what you do is you compare it to the alkane, the fully saturated alkane, CnH2n plus 2, or C5, H2 times 5 plus 2, H12. This is missing 4 hydrogens off of it, and you divide that number by 2, and that tells you the degree of unsaturation. Does this sound familiar to Chamberlain people? Okay, they're arguing amongst each other right now. Wait, do I need to say more right now? Okay, I'll say a little bit more, but I can't redo everything, unfortunately. And maybe you had, I don't know. I don't know how you would do this otherwise. Okay, she could have thought of a different method, I'm not sure. Which is totally fine. This is the way I do it. Okay, you gotta remember this thing right here. CnH2n plus 2. You plug in for the number of carbons, 5. And then you go 2 times 5 plus 2, that's 12. It is missing 4 hydrogens. That's where this 4 is. You divide by 2, and that gives me 2. This is called the degree of unsaturation. So what that means is, unfortunately, you're learning on a harder problem, that either there's a double bond, the 2 extra bonds on it cause each a degree of unsaturation, or 4 missing hydrogens, or there's 2 double bonds, or there's 2 rings, or there's a double bond and a ring. So all of those 4 possibilities are in play right now. Yeah. So if you want to see more about my style of doing it, you can watch one of my videos on iTunes. Yeah. That formula is for a saturated alkane. That's the only one, as far as I'm concerned, you need to know. Yeah? Alright, so now what do? I would say, okay, draw the longest, I like to do chains before rings. So I draw the longest chain of 5. Okay? And then I draw shorter, so I'm not doing the problem yet, I'm just kind of doing scratch work. And then I draw one shorter chain of 4 with an extra branch or carbon. And then I draw the shortest chain possible, 3, and this would have 2 branches. So all of those examples have 5 carbons. Those are the fully saturated alkanes, not my question. So I'm getting to my question in just a second. Okay? So this is scratch work. Now, I'm going to put a triple bond on all of these in as many places as I can. So for example, this is a hard example, I think. Okay. I can put the triple bond here. Or I can put the triple bond here. I think those are the only 2 choices on this one. Okay? I might not finish the problem because this looks really crazy. Then I go to the next one. Where are all the places I can put a triple bond? So I go, oh, okay. I can't put it anywhere there, but I can put it here. Why can't I put it here? There'd be more than 4 bonds on a carbon. So it can't be here, it can't be there, but it could be there. And then, is there anywhere I can put a triple bond here? No, because that would have too many bonds on it. So, here's with these template, these are my 3 possibilities with triple bond. Now I have to do the same thing with 2 double bonds. All again. So for example, I start again at the 5. And I would go, okay, I guess I could put 2 double bonds in a row. I guess I could put them alternating. I guess I could put 1 on each end. I guess I could put 2 in the middle. Like that. What are all the possibilities? So now I have to do that here. And then I have to do that here. Does that make sense? My system? And then I would do that for 2 rings. And then I would do that for a ring and a double bond. Okay, you asked too hard of a question, so I'm not going to fully solve it here. But do you get the pattern? Okay. For fun, you could do that, but this would be too hard for a final. But it could be, on a final, I'd expect one that could be as difficult of anywhere from about 8 to 15 final answers. Somewhere in that range. This would have more like over 20 possible answers. This would probably be over 20. It's my guess. Okay, yes. How do you do 2 rings? I always spend a little bit of time on this. A ring can touch on a side or a point. So, a point would be like this, a bow tie, if you think. Or a side would be like this. 1, 2, 3, 4, 5. Yeah. Something like that.
That's how
you gotta count, make sure at the end you got 5. Okay? Can I move on? Sorry. Good question. Too hard for a final, but fun to kind of warm up on. Yeah. Ready to move on? Next is naming. But this, I would say, is really critical for any question. This calculation. For my style. If you learn a different style in your class, totally fine. Alright, next, chirality. No, wait, did I say naming? I said naming. Okay. Back it on up. Let's say we had to name this. So if it's a chain, you want to find the longest chain. What's the longest chain? Yeah, let's trace it. Different color. 1, 2, 3, and going up here. So that'd be 1, 2, 3, 4, 5, 6 would be the longest chain. So we call that a hexane. And then there's 3 kind of branches, or what's called substituents. Those are all called methyl And there's 3 of them, so we call it trimethyl. And then we also have to note the location of the methyl on the chain. So we have to number this. So this is, we've got a methyl in the 2, the 3, and the 4 position. So if this would be 2, comma, 3, oops, comma, 4, dash, tri, methyl, hexane. You want to do another one? Okay, second one. Any questions on this one? Well, let me draw one here and I'll see if you have any questions. What do you want? Oh, they want a ring. You like that? That's cute. Okay. So it almost looks like a sheep missing one. Okay. So you've got a cyclohexane. Okay, we've got dimethyl, and we've got an ethyl. Okay, the 2. So you got to name each of the branches. Your main thing now is not the longest chain, but the ring. Okay. Yeah. A double bond would make an alkene, and you should only know how to name an alkane, cycloalkane, or organic halide. Okay. Are you fine? Okay, let me say it like this. I only taught alkanes, cycloalkanes, and organic halides. Does that answer your question? Okay. So theoretically, what's on the final is what both of us taught. All right. And that's as clear as possible. Okay. So you gotta name this in order. E before M. And then you need a low set of numbers. So where should my 1 be? Yeah, let's try this. 1, 2, 3, 4, 5, 6. Let's see if this gives us a low set of numbers. This would be a 1, comma 1 dash, and this would be a 2 dash. So yeah, that's a great low set of numbers. 2 ethyl, 1, 1 dimethyl, cyclohexane. Okay, any questions on that one? Yeah.
Would it be okay to start at the ethyl and go counting?
If you want to start counting here, then you'd have a 1, 2, 2. And so I have a lower set of numbers. I have a 1, 1, 2. Okay, good. I'm glad that was helpful for people. The lower complete set of numbers is what I'm looking for. All right. Let's do chirality. R or S? R or S? Somebody got it already? I got S. So I got 1, 2, 3, 4. It's got to be S. Yeah. Any questions on that? Us now. You want another one? Okay, a harder one? Okay, let me draw a harder one because they're super excited about that. And then, yeah, let me draw a harder one and then I'll answer that question. Yeah. Do it for the one with the star at it. Okay, what was the question from the other person? Oh, take it back? Yes. 1, 2, 3, and 4? Yeah, that for most people is probably the hardest part. You want to go in order of the periodic table for molar mass at the first point of connection. So I'm comparing a Cl, a carbon, and an H. Well, H has the lowest molar mass, chlorine would have the highest, and 2 carbons tie. And once you have a tie, you need to go to the next point of connection. Well, this is bonded to H's, which is cool, but this is bonded to H's and a carbon. Or basically, the longer chain is going to have priority. So that's why this is 2 on the left versus 3 on the right. Is that okay? Any other questions before we do the hard one? Yeah? How do I get the S? What method are you using to get RS? Yeah, I can do the thumb. So 4 is where your thumb is. So you're pointing this way towards you. Okay? And then your wrist is 1. And your knuckles are 2 and your fingertip is 3. So can you go 1 to 2 to 3 with your right hand? No. You have to break your fingers to do that. But with your left, 1 to 2 is your knuckles, remember, and 3 folds over, your fingers fold over to 3. It's S. Because you can use your left hand to do that. Is that okay? Okay. Any other questions on that? There's other methods, but if that's what you learn, just stick with it. It's fine. All right, ready for this one? What do you get? I think I got S also. Draw in the hydrogen, number it. 4, 3, 2, 1. It's kind of the same as the previous, if you like your thumb method. 4, and then 1 down here at the bottom right, 2, kind of at the left-hand side, and 3 folds up to the upper right. Yeah, I can do that with my left hand, so that's nice. Yeah. How did I number it is the other question. So, hydrogen, carbon, carbon, carbon. So there's that's definitely 4, and then the 3-way tie with carbons. This carbon has all H's. This carbon has another carbon. And this carbon has 2 carbons. So this has the most carbons on itself. So that's 1. This has 1 less carbon on itself. So that's 2. And this has no carbons on it. So that's 3. Yes. That's the paper method. You want me to do that? Okay. There, for those of you not in my class, I taught another method that I'm going to do right now. It's called the paper method. Well, the paper method works where you take the 4 position, wherever it is, and you swap it with the dashed position, wherever that is. And you redraw the molecule. So I put 4 where the dash is. That happens to switch with 3 in this case. Now I put the numbers back in. 1, 2, 3, 4. And then I'll get another color. I'll do this in green. Draw an arc between 1 to 2 to 3. Forget 4. That turns a steering wheel to the right. So because I had to flip something, the original was S. Okay. When you're doing the paper method, you want the number 4. If that happens to be H, it might be. It might not be H. The number 4 position to be in the dashed position. If it's not, you swap 2. Okay. Ready to move on? Yes, question? Can you, only if H is in the wedge position. Doesn't always work. Okay, here we go.